We just spent some time simplifying square roots that weren't perfect as far as the numbers go. Now let's see how things work when it's variables that aren't perfect squares. We've got the square root of x cubed. And since I'm dealing with the square root, I want to think about this in terms of squares. X cubed is the same thing as x squared times x. And by our property, this is the square root of x squared times the square root of x. And the square root of x squared is just x. So this simplifies down to x root x. Let's try another one. The square root of b to the fifth. And I'm going to do this two ways. The first way would be to think about this in terms of squares. This is b squared times b squared times b. And we know the square root of b squared is just b. And the square root of b squared again is just b times the square root of b. Putting it back together, we get b squared times the square root of b. Now, a different way of thinking about this same problem is that the square root of b to the fifth is b to the fourth times b. And remember that b to the fourth is the same thing as b squared squared, which means we end up with b squared times the square root of b. It's exactly the same. I want to show you something that a former student of mine taught me dealing with this. I call this the Orndorff method for a kid named Richard Orndorff. This is how he thought of this. And I thought it was a great way. I have the square root of b to the fifth. This is one we just did. And a square root, well, that involves dealing with squares, so he always wrote a 2 out there just to remind himself of that. And he thought about this in terms of division. 2 goes into 5 2 times. So that means there'll be b squared outside. And 2 goes into 5 2 times with 1 left over. So there'll be b to the first on the inside. Some of you may find that really helpful, and that's how Richard thought about it. Let's try another one. You can use whatever method you want. The square root of p to the ninth. Go ahead and hit pause and try that one yourself. All right, I'm going to do this two different ways. So first I'll do this with the Orndorff method. Well, this is the square root, and 2 goes into 9 4 times. So it'll be p to the fourth on the outside with a 1 left over. So it'll be p to the first on the inside. If we did it using our property, well, p to the ninth is the same thing as p to the eighth times p. But p to the eighth is the same thing as p to the fourth squared. So the square root of p to the fourth squared, well, that's just p to the fourth with the square root of p left on the inside. Two different ways of thinking about it, but both ends up in the same place. Let's turn it up a notch. Don't get overwhelmed now. Let's look at the square root of 25y squared. Well, by our property, this is just the square root of 25 times the square root of y squared. And now we just have individual parts that we've done before. The square root of 25 is 5. The square root of y squared is just y. There's our answer. Let's try one more. The square root of 49v to the ninth. Well, by our property, this is the square root of 49 times the square root of v to the ninth. We know the square root of 49 is 7. I'm going to use the Orndorff method here on v to the ninth. 2 goes in 9 4 times, so it'd be v to the fourth on the outside with a 1 left over, so v to the first on the inside. My Final answer is 7 v to the 4th times the square root of v.